All right, so you have your script file for lesson 2, and if you click did you get your note cards already? If you get your note cards, so now you should have your script and your note card in your inventory, so you can open those up and look at those if you want to follow along. Alrighty then. So I wanted to go over, I just wanted to go over again, just to kind of clarify about floats and integers. All right, so, all right, so now there's different uses for integers. If you're counting something, especially if it's if you need an exact number, use an integer. If it's not extraordinarily large or extraordinarily small number, you know, if it fits in an integer and it doesn't have a dot, use an integer. And again, as I said in lesson 1, in LSL, integers are used for true or false. So if you want to do equals true, true in all uppercase, or equals false, false in uppercase, use an integer. These can be used for a person's age, a year, the number of items, your chat channel number, because chat channels are integers, and you'll see that anytime you look at a command that works with chat channels. Well, anytime you look up chat channels. All right, now floats. You're going to tend to want to use integers pretty much, I guess. Well, it depends. It depends. So floats, you use, if you need a number with a dot, then you use float, like 98.6, you're going to use a float. Now, if the number is, if you're counting something and it's extremely negative, and it's extremely large, or extremely, I mean, I'm talking like gigantic numbers. And this is important, it can be rounded off, because if you're working with floats and you got a number that's really, really big or really, really small, it might get rounded off. And if you got a number that's got, let's say, a lot of digits after the decimal, that could be rounded off also. So that's the risk with floats, is that there's the possibility that they will be rounded off. So, so the temperature of something, you would use a float. The height of something, if you're measuring in meters, you use a float. The world population, population of the world. If you're, let's say, you're taking the population of every country in the world and you're adding them together, well, you're going to need something that holds an extraordinarily large number, but it doesn't need to be perfect. So if it gets rounded off a little bit, if the number's not 100% exact, it's okay. Then you can use a float. All right. So, but pretty much, it's kind of pretty much when in doubt, use an integer. Is basically the rule. You know, if you can't use an integer, then use a float. But note that a float cannot be used for an exact number or an exact count. All right. Floats also take more processing power. So it takes more work for the computer to calculate floats than it does for it to calculate integers, to add them together, to multiply them, etc. All right. So we're going to look at if statements. So we got some examples here of if statements. And now the if statement is if the condition is true, then the code runs. So you see the first if statement. Just a sec. Sorry about that. All right, so we see the first if statement. Does 5 equal 5? Okay, now notice we're using 2 equal sign. Okay, this is important. 2 equal signs means is equal to. So if you want to check to see if two things are the same, you use 2 equal signs. If you want to assign something a value, in other words, if you want to change the value of a variable, you use 1 equal sign. That changes the contents of a variable as 1 equal sign. But to compare, you use 2 equal signs. So is 5 equal to 5? Yes, of course it is. So the first thing in brackets, it's true, is going to be displayed. The next one, we have 2 variables. It's not shown here, but IA and IB are both integer variables. What information do those 2 variables store? It doesn't actually say here, but if they're storing the same thing, then the second section right here, comparing 2 integers, is going to say it's true. We can compare other things besides integers. We can compare strings also to see if 2 strings are the same. Be careful when comparing floats because, like I said, those can be rounded off sometimes. So it's a little tricky if you're comparing floats. If you're comparing floats, you should probably check not use equals. You should probably check to see if it's less than a certain number or greater than a certain number, because you're not certain with floats. It's not certain that you're going to get the exact number. You know, that the exact number that you store is actually going to be the exact number that's going to be stored, because sometimes it gets rounded off. Integers get rounded off sometimes. And so that's a problem with integers. All right. Now on the last one, we're actually using an integer, but b power on is storing either true, all capitals, or false, all capitals. In reality, true and false are both represented by numbers. One of them is represented by 0, one of them is represented by 1. So the integers 0 and the integer 1 can be replaced for the integers true and false. I think it's false is 0. False is 0, I think. So anyway, now you see if b power on has true in it, the number that represents true, then that code will run. So I'm just going to check. I'm just going to check real quick. LSL false. Actually, it was in my other note card too. Okay, yeah. False in all capitals is 0. So false in all capitals and the integer 0, they're the same thing. They can be used interchangeably. True in all capitals and the integer 1 can be used interchangeably. They can be used interchangeably safely because they are basically the same thing. So, alrighty then. So like I said, if the condition in parentheses is true, then the code in brackets runs. My cat's being a pain. All right. So now we don't just have is equal to. We also have is not equal to. So when the two values are not equal to each other, the condition is true and the code in brackets runs. We also have less than. So if the number on the left of the less than symbol is smaller than the number on the right of the less than symbol, then the code runs. If blank is less than blank. Less than or equal to. If the numbers are equal to, or if the number on the left is smaller, then the code in brackets runs. We have greater than, and we have greater than or equal to. So we have 1, 2, 3, 4, 5, 6 different, these are called operators that we can use to compare numbers together. Well, equals and not equals can be used for other things. They can be used for strings, for text too. If the two pieces of text are not the same or not. We'll see that a little later. All right, moving on. Okay, move on. There it goes. I think did I go too fast? Yeah, okay. All right, so we have logical operators. Now, do not confuse this with bitwise. Bitwise is kind of a little advanced. It's used with binary numbers. We in our code, binary numbers are shown as either decimal or hexadecimal. So computers think in binary. Everything that the computer stores is in binary, which is ones and zeros. But in our code, it's represented. We represent it with either a decimal number or hexadecimal number. And bitwise is a special type of math that can only be done with binary. We use it with integers, but bitwise, we're not going to be using bitwise. We're going to be using logical. So make sure you don't get the two confused. Logical is what we're using. We have logical not, logical and logical or. So there's also bitwise not, bitwise and bitwise or. That's why I say it's a little confusing. So you make sure you say logical. Make sure you include the word logical so that you know and everybody else knows that you're not talking about bitwise. Okay, so different programming languages use different symbols for these. So unlike the other operators that I showed you, unlike these are pretty much all programming languages use the same symbols for uh, these operators. But the logical operators, different programming languages use different symbols. And since I use more than one programming language, I always, every single time, check the wiki to make sure I'm using the right symbol. Make sure I'm not confusing LSL's logical and symbol with the logical and symbol of a different language. So always check the wiki and make sure you check for logical. Okay, so what do these do? This gets a little bit complicated. So here we have, this barely fit on the screen. I had to, anyway. Yeah, wow. Okay, so we got the first one. All right, the first one, IA is equal to IB and B power on, logical and B power on. So, okay, so the logical operators are and or not, as we went over. So what is the first statement? What does the first piece of code do? So the first piece of code, if both conditions are true. So not only does IA have to be equal to IB, that has to be true, and B power on has to be true. So the value of B power on has to be true, and the value of IA has to be the same as the value of IB. Both conditions must be met for that first section in brackets to be run. And then if both conditions are met, the script will say both conditions are true. Now we got the second one, we got a logical or between them. Now what this means, if one or both conditions are true. So if IA is equal to IB, this will run. This code in brackets will run. If B power on is equal to true, this code will run. If both those things are true, this code will run. So it's either or both. So either condition can be true. If either the condition on the left, IA equals IB, if that's true, it runs. If the condition on the right, B power on, is true, then it runs. If both of them are true, it runs. Now we have the not. The bottom one is we have the exclamation mark symbol, which is not. Now, this basically, this flips things around. It makes it not true. So if B power on is not true, then the condition runs. And it says power is off. In other words, B power on is set to false. All right, so that's a little bit complicated, but it can even get even more complicated than that. If that's not complex for you, if that's not advanced enough, and you need to do something more advanced, now we're getting into algebra. And this is what's called Boolean algebra. Logical operators. Logical operators mean Boolean. Logical operators are Boolean logic. Now, as with algebra, what's in the innermost parentheses is run first. So, first of all, we go okay, is this code in the innermost parentheses true or not? So if IA is equal to IB, then the first condition in the innermost parentheses is true. If IC is equal to ID, then the condition in the innermost parentheses is true. If both of those, if IA is equal to IB and IC is equal to ID, then the condition in the innermost parentheses is also true. The only way the condition in the innermost parentheses is false is if both those things are false. If IA is not equal to IB and IC is not equal to ID, that's the only time that the condition in the innermost parentheses is false. Now, after we evaluate that, okay, let's say the condition in the innermost parentheses is true. Okay, let's say one of those two things is true. Let's say IA is equal to IB, right? Let's say those two equal each other. Then automatically those conditions in that inner parentheses is true. Now we got to see, is that true and power on is true? Okay, so now we know the first condition to the left of the and code, to the left of the two ampersands, that's true. But the condition to the right of the two ampersands also has to be true. So is that condition is true, but is B power on also true? And if both those conditions are met, then it says power is on and at least one pair of integers match. So that what it says kind of describes what's going on here. So the power has to be on, which means power on has to be equal to true, and one of those two pairs of integers have to match each other, or both of those two pairs of integers. If one or both of the two conditions, IA equals IB, IC equals ID is true, and B power on is true, then the code in brackets runs. If all those conditions are not met, then the code in brackets doesn't run. Right? I hope that's not too complicated. Did everyone get that? So it's algebra. Yeah, it's complicated. So I probably should have broke this down a little more, but okay. So we're nesting them. What is in the innermost parentheses is evaluated first. So first we look at what's in the innermost parentheses, which is IA equals IB or IC equals ID. So we're first looking at those innermost parentheses, and we're trying to figure out if all that code in the innermost parentheses, just the innermost parentheses, is true or false. Once we figure out if that's false or true, for example, let's see, we figure out that's true. Okay, so that's true. Now we have to figure out if that's true and B power on is true. Okay, so if the condition in the innermost parentheses is true and B power on is true, that's the only time this code is going to run. So the innermost parentheses, you have to figure out if that's true. If it is true, if the computer figures out that that is true, and B power on is also true, then the code runs. If B power on is false, the code doesn't run at all, because both conditions have to be true. Okay, You got it now? I know it's, you might have to look at this for a minute to just, I'm going to leave it here for a few more seconds. All right. Now that's about as complicated as it gets, pretty much. You can make this more complicated if you want to by adding more sets of parentheses. If you want to. But you don't want it to get so confusing that you don't understand it yourself. But anyway, let's move on. Now we have else. Else statements work with if to specify what happens when the if condition doesn't run. So the else condition only runs if the if condition doesn't run. So if the first sets of brackets, if the code in the first sets of brackets doesn't run, then the code in the second sets of brackets run. If the code in the first sets of brackets does run, then the code in the second set doesn't run. So only one, in this example right here, only one of these LLC codes is going to run. Only one of them is going to run. If B power on is set to true, then the first block of code is run. If it's not set to true, the second block of code is run. That's how we use this else. It's basically else is like a catch. So if the condition is not met, this is what we do. All right. So now I'm going to go on to what's else if. Okay. Now else if allows to chain multiple conditions. You can have as many else if statements as you want. If we don't include an else block after the last else if block, then none of the code in brackets will run. I'm sorry, I meant to say none of the code in brackets will run if none of the conditions are met. So here we don't have an else statement after the last else if. We could, in the script I gave you, we do. But in this condition, okay, so if our variable doesn't contain the word green and our variable doesn't contain the word blue, then none of this code runs. Okay, so first it checks to see if our variable has the word green. Now, only if that's false does the second condition get checked. So only if our color is not green does the computer check to see if it's blue. If it's green, then it says the color is green. I mean the color of grass. If it's green, if the color is green, then it says the color of grass, and the second condition doesn't even get checked. The computer doesn't even look to see if it's equal to blue. But if it's not green, then the second condition gets checked, and the computer checks to see if it's blue. If it's blue, it says the color of the sky. If it's not blue, it doesn't do anything. But we could put an else statement at the end of this. I should have put a slide up showing it, but we could, if we wanted to, put just an else, not an else if, but just an else as a catch-all that says that is an invalid color. And in fact, if you go into the script that I gave you, if you open up LSL Lesson 2, the script, not the note card, the script, you got to scroll way, or is it all the way at the bottom? Yeah, it's all the way at the bottom. Okay, it's all the way at the bottom. Okay, so if you open up the script file, LSL Lesson 2, the script, not the note card, all right, it's got, the icon looks a little different. It's got a green and red dot square on it. All right, so if you open that up, way on the bottom, you see we did include an else statement as a catch-all. And that catch-all, oh no, actually that's another else if. We made this a little, we improved on this a little bit. So we included the else if str color equals red, but our catch-all is the very last else, where it says this is not a valid color. So that last else is our catch-all. If we didn't have that last else and it was an invalid color, nothing would happen. So without that last else, nothing happens if it's an invalid color. With that last else, if it's an invalid color, it says so. So that's optional. You decide. It's a case-by-case decision. Do you want to include an else after the last else if or not? How many else ifs do you want to include? You know, that all depends on what script you're writing. That all depends on the code you're writing. So you can do an if, you can do if else, you can do if else if, else if, else if, else, you know, anything you want. Have fun. All right, so this is a screenshot from, this is a picture of the LSL wiki, and it's talking about the function called listen. LL Listen, I'm sorry, LL Listen. Now, I'm teaching you another built-in function, and this is the one you've all been waiting for. How do you make your code respond to commands, verbal commands? So we're going to use spoken commands, okay? So we see LL Listen has 4 arguments. All right, the first one is the channel, okay? Now, if you type /1 space and then a message, that message will be sent on channel 1. If you type in /87 space and then a message, that message will be sent on channel 87. Messages that are sent on channels other than 0 are not displayed. So we have a channel. So LL Listen, what LL Listen does is it creates a handle. It creates a listen handle. We customize the listen handle. What channel do we want to listen to? What channel do we want our script to listen to? What item or person or avatar do we want to listen to? Like the name, we can specify the name of a particular prim that our a particular object that our script is listening to. We can specify the name of a particular avatar that our script is listening to. We can leave that blank if we want. We can specify the ID, the UUID of, that's what a key is. A key is a UUID, which is a special code. It's a special hexadecimal, very long hexadecimal number that identifies a prim, an avatar, or any type of item. All our items in Second Life and in online virtual world, all our items have a special unique ID called a UUID, and that's referred to as a key. So that's another data type, is the key data type. So we can have our listen for a specific group, a specific avatar, or a particular prim, and we can specify it by the UUID. So we could use an avatar's name, or we could use an avatar's UUID. We get to choose. We can filter for specific messages, which is something I don't see a lot of use for, to filter for specific messages, because I think it's better just to listen to all messages and then later decide what to do based on what message we have. So I don't really recommend using string message for the LL Listen. It's kind of, it's not really that useful, because I mean, unless you're only listening to one specific message, only if your code only responds to one specific command, then yeah. But chances are your script is not going to only respond to one specific command. So I don't really see the point in specifying message. So here I'm going to get into how this works. These aren't in order. All right. Okay, so handles are resources like prims, so be sure to remove them when they are no longer needed. When a prim is deleted, its handles are automatically removed. Okay, so we don't want to create a lot of listen handles. We want to create as few as we need. We don't want to create any more. We don't want to run LL Listen any more times than we need to. All right. Now, and you see the LL Listen returns a handle. The handle is used to stop listening. So we can do listen handle equals LL Listen. Now, here, I left almost everything blank. Strings, to leave a string blank, you have to do 2 sets of double quotes. To leave a key blank, you have to do null key. You have to spell it exactly like that, capital NULL underscore capital key AEY. And it says that on the wiki. It actually tells you that on the wiki. If you look at the LL Listen on the wiki, let's go back to that real quick. If you notice, somewhere on here it says it. Okay, yeah. On the very bottom, if message name or ID are blank, if message name or ID are blank, i.e. Empty string, quote unquote, they are not used to filter incoming messages. If ID is an invalid key or assign the value null key, it is considered blank as well. So that tells you how to leave those values blank. I recommend always consulting this page when you're using listen. I'm always consulting the manual. I don't go by memory a lot of the times. It's not good to go by memory a lot. It's good to verify, because we can forget very easily. So now in this case, I use the number 1. Now you could use any number you want. And you could even use negative. Well, you can't use any number you want. It's limited to the size of an integer, which is what, like a million something. But you can use You can use a very large number. You can use a very small number. So it's like 2 billion. So you can use like you can use negative 2 billion. You can use positive 2 billion. You can use 87. You could use 1. You can use -1, -87. If you want to listen to public chat, you use 0. Use 0, and everything that's typed, if you use 0, everything that everybody types, as long as they don't use a /1 or a /87, will be listened to. In this case, I use a 1. Now, you can also use negative numbers. Why would you use the negative numbers? You can't, people cannot send text on negative channels. Items can, though. Objects can send messages on negative channels, but people cannot. So that's a good thing to memorize. Yes. If you want it to be able to respond to avatars, use a positive channel. If you don't want it to be able to respond to avatars and you only want it to respond to other objects, use a negative channel. All right. Now, when our script doesn't need to listen anymore on that particular channel, we use listen remove. We can actually do more than one handle. Like if we could do listen handle 1, listen handle 2, listen handle 3, and then we can do LL listen remove, listen handle 1, LL listen remove, listen handle 2. But you know, if your script doesn't need to be listening anymore, use LL listen remove to get rid of that listen handle if you don't need it. But remember, when your object is deleted, those listen handles are automatically removed. So we don't want to create too many listen handles. We only want to create as many as we need. Listen handle is actually integer. So we would do integer listen handle. And yeah, like I said, every time we call LL listen, we are creating a listen handle. Just like prims, the more there are, the more strain it puts on the region. Use LL listen remove to get rid of ones that we don't need. All right, so I'm going to do a demonstration here. I'm going to pick on you, Social Mouse. Type slash, the slash that's under the question mark, 1, and then put a space, and then type in the name of a color in all lowercase. I'll let you, the prim, give you the instructions. I'm going to click on, right, there you go, you got it. So if we click on lesson 2, we see it does some math. Somebody just said the color blue on channel 1. So it says here, where is it? Somewhere here it says it. It didn't say it. All right. Anyway, yeah, so you can see how it works. Now, if I had it listening on channel 0, you wouldn't have to put /1 space. You would just type the color and it would respond. So it checks for a few different colors. You know, I can do /1 space red, and lesson 2 is responding with the color of lips. And that's our else if. Somebody just said green. That's our else if. So we're using our else if statements to if you open up your script and go all the way to the bottom, you see that it can catch different colors. We have a catch for green, we have a catch for blue, we have a catch for red. We can add colors in here too. We could add purple, we could add yellow, we could put yellow, color of a flower, or the color of whatever you want. And I encourage you to do that. Edit this and add some else if statements, add some more else if statements here to listen for different colors. So only one of the conditions in the if, else if, else if, else if, else, only one of those things in brackets is run. Because the key word there is else, meaning I'm going to do this. Like if I say, I'm going to go to the store, if I'm going to go into the store if it's open, else I'm going to go into Stop and Shop if it's open, else I'm going to go into Walgreens. Now, which if Stop and Shop is open, I'm not going to go into Walgreens. Else means if that's not true, then we check the next thing. If it is true, then we stop checking stuff. All right. So I hope I explained else if enough. Let's move on to while loops. While loops are used to do something multiple times. The condition is checked. If it is true, the code in brackets is run. Then the condition is checked again. If it is true again, the code in brackets is run again. And this just keeps repeating over and over and over again until the condition in brackets is false. So here we go with our while. Okay, first we're setting I to equal 0. Okay, so we're creating a variable named I, which holds an integer. This integer is going to be 0. It's going to start off as 0. Now, while I is less than 3, is 0 less than 3? Yes, it is. So our code gets run. What does it do? It says the value of I, in this case 0. Then the value of I gets increased. There are a few different ways to increase a variable. I know there are there's basically 3 different ways to do it. If you look at your note card, under the while section, the bottom of the while section, you see that there's 3 different ways to take a variable and add 1 to it. You can do the variable name with 2 pluses after it. You could do the variable name, a plus and equals, and then the number 1 after it. You do the variable name and equal sign, and then the variable name again plus 1. So there's a few different ways to add 1. Plus equals takes the value and adds something to it. So I plus equals 1 increases I by 1. I plus equals 2 would increase I by 2. So we can use plus plus, or we can use plus equals. Plus plus is what most people do. Plus plus is the best way if you're just going up by 1. Just use plus plus. That's the way the professionals do it. All right, so I is no longer 0. It's now 1. Is 1 less than 3? I'm sure you all know 1 is less than 3. So the code gets run a second time. This time it says 1. Then the condition is checked again. No, I'm sorry. I goes up again. So I is no longer 1. I goes up again and increases to 2. Is 2 less than 3? Yes, it is. So the condition gets run again. It says 2, and then it increases I to 3. Now the while condition gets checked again. Is I, now I contains the value 3. Is 3 less than 3? 3 is not less than 3. So the code doesn't get run. So this is a simple way to count from 0 to 2. In computers usually count from 0. We usually count from 0 in computers. So we're counting from 0 to 2. So this is a simple way. If you want something to be done 3 times, you can use this code right here. And this will do whatever you want 3 times. You change the 3 to a 8, it'll do whatever you want 8 times. It'll do whatever's in the brackets 8 times. Just make sure you include the I++ at the end. You can put whatever code you want in the brackets. Just make sure I++ semicolon is the last command. Alrighty then. Now we're going to see something that's very similar. This is a for loop, also known as a for and do loop. This is another example that counts from 0 to 2. It's called for and do because the condition is broken down into 3 parts. We have the initializer, which is also known as the for part. That's I equals 0. We have the condition, also known as in, which is I less than 3. And we have the do part. I gets increased by 1. So it can also be said for I equals 0 in I less than 3, do increase I. All right, so just to put it simple, first we're setting the variable. The first thing we're doing is setting the variable I to equal 0, okay? So that gets done once in our for loop. That only gets done once. I gets set to equal 0. Then we check to see if I is less than 3. If I is less than 3, then we run the code. Now, after we run the code, says the number 0. Then after the code is run, then I++ gets run, and we increase I from 0 to 1. Then we go back to step 2. Is I less than 3? Well, 1 is less than 3. So the code gets run again, and it says 1, because I is 1. And then we increase I to 2. Then is 2 less than 3? Yes, it is. So the code gets run a third time. And the code says 2. And then I gets increased to 3. I++. Is 3 less than 3? No. So the code doesn't get run. So this is exactly the same as our while loop. This does the exact same thing as our while loop. I'm not sure if the value of I is the same after our for loop runs as it is after our while loop runs. That doesn't really matter too much. I think that's different in different languages. Is I does I end up having the same value after 4 runs than it does after while runs? I'm not exactly sure, but that's not really relevant too much in this case. But other than that, it does exactly the same thing. And it will both will display 0, 1, 2. And that's it. So any questions? Anything that needs to be clarified or explained a little better, or all right.
I do have a question. The part of scripting that confuses me a little bit, because like I said,
Your sound just died. The sound just died.
Statement, but my complications come in like when the script, well, I think we didn't talk about that part yet. But when scripts talk to each other, I think is a little bit confusing for me. You see how when we did just now where it says, let me do a /1 space red. So the script is listening to that channel, and if it sees me, if it knows that I typed in red, then it checks against the script, and then it will say the color of lips, right? So that's like a listener, right?
It is a listener, yeah.
It is a listener.
We have a listen
okay.
handle. We have a listen handle that's being used. We're using one listen handle, and this particular listen handle that we're using and that we created is it's set to channel 1. It's set to listen on channel 1. So anytime somebody types something on channel 1, did I lose my sound?
My flames here for burn up everything. Now for loop also called do end. Now in the beginning, confused me a little bit all the way in the beginning when we was talking about, oh my god, I just remember the symbols. I put it out. This and this.
Okay.
Those symbols.
Okay. That's
now that logical, I got a tiny bit, but I don't know. Okay, go ahead. Sorry.
That's logical not and logical and. So if you logical and means if this and this is true. So like if I'm going to the store and the store is open, I will go inside the store and buy something. Like if I'm going to the store and the store is open, I'm going to buy some bread. Both conditions have to be met.
Back up with the statements just so I can review it one more time. Hold on, I have my note card up too. I just wanted to.
So
and my script. Oh no, not that one.
If I'm going to the store and the store is open, then I'm going to buy bread.
Okay.
So both conditions have to be true. I'm trying to go back here. Okay, both conditions have to be true. A and B are the same, and B power on is true. Both conditions have to be met. And you can use you could put another and symbol, the 2 ampersands after B power on in that very top, the very top line.
Yes.
And then put another condition too. So you can do like 3 conditions, 4 conditions, and separate them with and signs, with and symbols. Now, if you're using more than one symbol, then that's where we have the parentheses. So in this case, we're using the or symbol and we're using the and symbol. So that's why we have to use parentheses in this case. Because if we don't use parentheses, then it's very confusing as to what happens first. If you've just got three conditions separated with the and symbol, that's fine. If you have three conditions separated with the or symbol, that's fine.
Three conditions. Now, conditions is, I thought conditions is with the if else thing, right?
Yeah, like a condition is, what I mean by condition is IA equal to IB. That's a condition.
Okay.
That's what I mean by that.
Okay, I see what you're saying. So the IA equals IB is one condition. Second condition is that IC equals ID.
Yeah.
And then, and if any of that is true, then it powers on. Is that how that works?
Well, in this case, what's in parentheses, what's in the innermost parentheses, has to be true, and B power on has to be true.
Okay. So the double ampersands are just basically saying and.
Correct. Logical and.
Okay.
Make sure to distinguish logical and.
Now, would that same argument work if I did indeed just add the word and, or that's not in the LSL language?
No. In LSL,
okay,
we have to use two ampersands for logical and.
Okay.
That's the way the language is. And remember, that's different in different languages. So if you go to another language, they might not use double ampersand. They may use something else.
Okay. This is getting funner the more I learn a little bit. I can't wait to try my hand at making something from scratch, I should say. Make something from scratch. Yeah. Let's see if I have one more question. Nope, I got the floats. I just want to make sure I didn't have anything else for you. Go.
Yeah, and
if statements.
I encourage you to take a copy of the LSL Lesson 2 and play around with the script, you know?
Yeah, I want to do that. Yeah.
But mess around with the copy. You always want to edit your copy. You don't want to edit your original. Make a copy of it and mess around with it. Well, when you res it from your inventory, it'll res a copy.
Okay.
Yeah, copyable items res a copy when you res from inventory. If the item is no copy, then it will res the original. But this is a copy item. This is a copyable item.
You just I don't know what a loop is. Can you explain again what a loop is?
Yeah. So
I'm sorry. That's my last question. I swear to God.
No. Don't worry about it. Don't worry about it. This is what. Let's go back. So a loop just basically what it means is that it runs over and over again. So in this case, what's in brackets will run over and over and over again until the condition in parentheses is not true. So it loops around. You get it?
Can you give me like a for example, like something that would happen? I don't know how to describe it, but can you tell me like what? Like loop what? Is it like an action? Is it like it's saying something? What is it looping?
Okay, it's looping the code that's in brackets is what it's looping. So
Code
it's
that's in brackets.
so where it says LLC and where it says I++, those two lines of code are being run over and over again. In this case, they're being run 3 times because after they're run, they run the first time, second time. After they run 3 times, the condition is no longer true. Because after that code in brackets runs 3 times, I is then bumped up to 3. So first I starts at 0. The first time the code runs, I is bumped up to 1. The second time the code in brackets is run, I is bumped up to 2. The third time the code in brackets is run, I is bumped up to 3. And then it doesn't run again because 3 is not less than 3. So that's when it stops. If you were to replace the I, if you were to do while, if you were to replace, like if you would use, like if you wanted to do while 7 equals 7, then you'd have what's called an infinite loop. Because 7 is always going to be equal to 7. So if you change that while statement to while 7 equals 7, then that code's going to run over and over and over again. And everybody around the prim is going to get very annoyed.
Very spammy code.
Exactly. It's just going to spam everyone.
Okay.
So
now, for this example, go ahead.
Always test your loops. Always be testing while you're writing your code. Go ahead.
Okay, so this one, it says say. So is it actually going to do anything, this little sample here?
Say is an internal command. LL say is an internal, it's part of LSL. And this, it says on channel 0, which means that everybody can see it. And it takes the variable I and it turns it into a string. So the first time this code runs, it's going to say 0. The second time, it's going to say 1. And then the third time, it's going to say 2. So it's going to say 0, 1, 2. That's all this code does, is count from 0 to 2.
Okay, no, that makes sense. Okay.
And this code does the same thing. It counts from 0 to 2. It's basically the same thing. It's just written a little differently. See, we still have the I equals 0 like we had in the while statement. We still have the I less than 3 like we had in the while statement. And we still have the I++ like we had in the while statement. For one's a little complicated.
I want to play with that script there that says like the colors and stuff. I want to see if I can set it to listen to the public channel. And then when people say keywords, it says something, which I think would be cool. You know?
Yeah, that would be easy to do. Is this thing working? Test. Can you hear me?
I'll see.
Okay, there we go.
I can hear you. Yep.
That would be very easy to do. All you'd have to do is change the 1 to a 0. So instead of listening, let me go back here. Taking some time to rise. Okay, so where it says LL Listen, If you change that 1 to a 0, that will listen on the public channel. That's all you'd have to change to make it listen on the public channel.
Okay, cool. Yes, LL listen. I was just looking for it. Okay, listen handle equals LL listen 1. Okay, yep. I can turn that to 0, and then I can change the little statements here around, and it'll be cool. No, this will be cool.
Yep. Exactly. And you can change the statements. You can change your statements instead of looking for, can you hear me?
I have to edit the whole thing above it or just that little excerpt?
Just the number 1. Just change the 1 to a 0, and it'll listen to public. And you can also change.
Okay.
Yeah, you can also change like if you wanted to listen to other things besides colors, you could change green to whatever text you want it to listen to. You could add else if statements there to check for other things.
Okay.
Now, if it's a sentence.
You count? Look like you're doubled over there.
Now, if somebody types a sentence with the word green in it, the script won't respond. It will only respond if that's the only text. So if you did /1, I am green, it's going to say, well, it'll still respond. It'll say that is not a valid color.
Okay, so what you're saying is it may not be possible for me to change that script around. So instead of, if I change it to listen on a public channel and someone types in a sentence, I'm just going to put, I'm not green. It won't pick up that they're even using the word green. It'll have to be just green out and out.
Correct. The way the script is made. It can be changed, though. You can change it. What you would have to do is you'd have to add code to search for the word green. You have to add some code in there. So instead of the message being the word green, it searches the message, and if it finds the word green in the message, then it says grass is green. You'd have to change it. You'd have to add another function in there, another LSL function.
Okay. I got it now. Just writing some stuff down so I can remember.
Cool. Very good. Very good. The way it is now, it only works if the word green is by itself, not in a sentence. But you can make it so that it works when the word green is in a sentence.
And you said I can find that in the wiki, right?
Yes, you can. I mean, I would just do a search for like LSL search string. You know, just go into like a regular search engine and just go, you know, LSL.
That I can do.
That's what I would do, because I don't remember. I honestly don't remember what the name of the function is off the top of my head. LSL search string, and probably find. Okay, there it is. LL substring index. See it popped up? If you look on the browser. If you mouse over the
Hold
browser.
on, it's white for me. Hold on, I gotta click on it. It's white for me. Let me push. Okay, it's gonna come up. Hold on.
Yeah, and you click the magnifying glass.
There we go. Yeah, I see it now. No, I just had to wait for it to load here. Okay, yes, I see it. LL string.
LL
Actually, can I
substring
click?
index.
I can't. Oop, this one. Okay, LL subscreen.
It's the second
Okay.
link. LL substring index.
Yeah, I see it.
Yep. There you go. There you go. That's how to do it. So it's a little tricky. This is a little tricky. So you could probably figure this out. You could. This is working. You could probably figure this one out.
Let me make sure I got it. Yep, I got it. Okay. String sort patterns. Okay, so this is what I need to look at to get what I need. Okay. I have the website down. You probably could figure it out. Yeah, I think I can. I think I can.
So if it's not -1, then it found it. If pattern is not found, it's -1. If pattern is found, then it's not -1. Alrighty then. So I guess for next time, go over dialog boxes and working with strings. I guess would be a good place to go. Any suggestions for the next lesson?
Okay. Well, hopefully I have a new toy for us to play with when you come back. Any suggestions for the next lesson? I'm thinking dialog boxes and working with strings. Oh God, yes.